Let me get started. And as Linda mentioned, I'm going to be talking about those topics, 3G, moving to LPWAN to 5G. But before I do that, I want to give you a little bit of information about the company, who we are, and why this is an important topic for us, and how we help people make that migration happen for their connectivity. We are a global technology partner in the IoT space. If a company has a need for connecting their product, if it's a currently unconnected product, to connected services anywhere in the world, that's what we do. We help people make that transition from unconnected devices to connected services for their customers. We have a significant presence around the world. Our headquarters are in Silicon Valley in San Jose, with operations sprinkled around the world to support people in the UK, in Europe, in India, Japan, the Far East. And we have our own network operating centers sprinkled around the world as well. There are two solutions we offer. One is called the Aeris Fusion IoT Network, and the other one is the Aeris Automotive Platform. I'm not going to be talking about those today. I'm going to be talking just about the connectivity elements within those two solutions, because the Fusion network comprises the connectivity that we allow customers to use. We can get customers to use for the services that we have, and that has a little bit more nuances to it, which would be the topic of a different webinar. And our automotive platform is a specific development and delivery platform for the automotive industry. The markets we serve are the traditional IoT markets, such as connected cars, fleets, healthcare, financial, industrial IoT, utility markets, etc. You name it, if an IoT need exists, we can support that. In terms of the numbers, let's talk a little bit about that. We have operational reach for our cellular IoT services, the Fusion IoT network as well, in 180 different countries. Now, do we have devices in all 180 countries? Not yet, but a significant number of them. We currently have about 15 million devices on the network, and we're processing well over 1 billion, almost 1.5 billion messages, IoT data messages per day. We're ranked in the top 10 in terms of the number of units we have deployed around the world, number 3 in the United States, top 10 around the world. The reason this is important, and I'm going to make sure that people understand why IoT is a big deal, is that the markets are enormous. And this is a slide put together by McKinsey, which shows that the expectations are that in another 5 years, this could be an extremely large market, somewhere between $4 trillion to $11 trillion. Now, obviously, there's a variability here depending on the outcomes in any given market. But as you can see from their estimates, IoT has impact in just about every market you can think of, whether it's for vehicles, which is a traditional connected car kind of solutions, are traditional applications that people deploy, all the way around to work sites and human health and services, which I think would be potentially a larger market, given the experiences we've all had in the past 4 or 5 months with the virus. So there are markets that IoT can impact, and the question is, what connectivity serves each of these markets as well as they should, depending on whether it is a vehicle out in the street, which would use a cellular solution, or a home device, which potentially could use a Bluetooth or a Wi-Fi solution. If you look at the global cellular technology deployments that have taken place in the past few years and what is expected to go forward, there are a large number of devices deployed. Now, this list here does not include IoT. It's the technology, information about the technology that is available. And as you can see, starting in about 2014, 2G started dropping because 3G became more widely available. And then 3G has stabilized, or by the time 4G was introduced, 4G was growing pretty rapidly. And if you look at the 2019, 2020, and the 2021 timeframe, 4G is the vast majority of the devices that are out there today. But you start seeing 5G coming on strong in the 2020 environment and growing steadily till 2024, where it becomes an important technology delivery. By that time, you'll start seeing 2G handsets, pure 2G handsets fading, and you'll start seeing the 4G and 5G become the dominant cellular technologies that are in play pretty much around the world. Lots of units, obviously, more than the population of the planet. 8.8 billion devices by 2024 is the prediction. But what about IoT? If you look at the connected devices, and now this includes all kinds of technologies used in IoT from a global perspective, from the 2018 to 2024 timeframe, you start seeing devices being deployed for applications like fixed phones. Okay, so they're not IoT, but that's the kind of devices that people will use in the wireless area. You have mobile phones, you have PCs and laptops, and then you have the two categories of IoT, which you have the short-range IoT and the wide area IoT. Now, I'm not going to focus on short-range IoT as much in this presentation. I'm going to spend more time on the wide area IoT and the cellular IoT solutions, but those are also growing significantly. Between 2018 and 2024, the compounded annual growth rate is well over 25%, 27% on the estimates provided here by Ericsson. Large, significant growth. And that's where, as you can see, both in the short-range IoT, which typically is home medical devices, your Fitbits and things like that, all the way up to the wide area IoT devices such as connected cars and industrial solutions that might need long-range remote control. Large growth. Let's focus a little bit deeper into the specifics associated with what technologies are in play. And as you can see, right around the 2018 and 19 timeframe, the legacy services, 2G, 3G, started fading or basically becoming stagnant because many countries had to remove the 2G services. And within the next year or two, you'll start seeing 3G going away as well. Now, that trend, now actually in here, Ericsson says that it'll kind of sort of flatten out by 2024 because they are looking at markets like Europe and Far East where 2G may still exist and in some places around the world, like in Africa as well. I personally believe that that number actually will drop more precipitously than is shown over here. What will come on strong are the new technologies from massive IoT, specifically narrowband IoT and LTE Category M, which I will talk about in a little bit more detail. And of course, where you start seeing 4G and 5G for the broadband IoT solution coming on strong as well. And by 2024, they're predicting about 4 billion devices worldwide, which is a significant number of units. And I'm going to focus more on those than I will focus on other technologies, but I'll be mentioning the other technologies that could come into play as well. Now, let's talk about LPWA first. The first area of technology migration that's occurring away from 3G and 2G in particular is low power wide area network. That's what LPWA stands for, low power wide area. If you look at it from the perspective of the kind of application units that can use these, there are many IoT applications that just need low data rates. They're only sending a few hundred bytes per packet, and they have a reasonable latency tolerance. The application couldn't really get affected whether the data comes through in a minute or an hour, or perhaps they're sending data from a tank monitoring system reporting the amount of fuel or liquid that might be inside the tank, and even a once-a-day kind of report would be sufficient. These kinds of applications typically have a few hundred kilobytes being transmitted per month, or maybe a megabyte or less kind of data requirements. The important criteria is if you look at the application, they need battery operation. Typically, when you're going into these applications, such as water meters or propane tanks, as I mentioned, you really don't have a source of electrical energy other than batteries. So you need to, for these batteries to survive, these units to survive transmitting for years on end without having to have somebody come by and recharge them or replace the batteries, etc. So typically, these technologies assume somewhere between 1 and 10 years of longevity on the batteries that are in there, maybe sending and receiving a few transmissions per day. Low latency, latency tolerant without having to worry about hundreds of megabytes of data or something like that. And of course, there's a requirement if you're going to get scale that the services and radio costs will be fairly significantly lower than what has been available in the past. So you're starting to see radio modules well below $10 in large volumes today. They're down in the few dollar ranges for certain technologies to maybe a little bit over $5 for the typical LPWA cellular technologies that are available, which I'll talk about in a minute. And the idea really is keep the volume, the cost low at high volume, because that's where the majority of LPWA devices will get deployed. Now, if you look at the categories of LPWA that is out there, there are two types. There's the proprietary technologies, which is exemplified by companies like Sigfox and Ingenu and the Low Power Radio Alliance, also called LoRa. And then you have the standards-based, the cellular standards-based technologies such as LTE-M as well as narrowband IoT, NB-IoT. The key differences between these are the sub-bullets that I identify over there. The proprietary technologies typically use unlicensed spectrum, so they can be used perhaps for a private network or maybe even a public commercial service such as Sigfox or Ingenu are looking at providing commercial networks in various countries around the world. LoRa is sort of one of the technologies, because it is an open standard, which I'll talk about a little bit more in a minute, allows you to do private networks fairly easily. Now, I'm not going to spend a lot of time on those. I'm going to spend more time on the standards-based technologies because these are licensed. the services that can be provided. We provide services in that arena along with other national carriers as well as IoT providers. It is our main source of growth expectations for people who are migrating from 2G and 3G to the LTE technologies, these category M technologies, as well as the narrowband IoT technologies. And it's important to realize that the coverage provided by this is subsidized effectively by smartphone users, so they can grow more rapidly, they can be available in more countries more rapidly without having to have a deployment that is driven by companies who don't have necessarily the coverage available to them, or if you're doing a private network, it gets expensive to start deploying those units out significantly beyond the scope of what you might be doing initially. The proprietary players, Sigfox engineered LoRa. Sigfox was developed and initially deployed in France, available in a large number of countries. They have a small capacity messaging transport, which is designed for the kinds of applications such as tank monitoring or basic utility meter reading, etc. Engineer was a company that had a very nice radio, allowed you to transmit in the presence of noise quite dramatically because they had an exceptionally good link budget. And that technology was initially deployed in the USA. They have the same model of deploying in certain countries around the world. And of course, there is the LoRa Alliance or LoRaWAN standard, which is used by a large number of supporting companies. Last time I looked, LoRaWAN had about 550 different companies who either supported it or provided product associated with the Alliance standard. And so you have a lot of sources. If you're putting together a private network, it is easy to get gateways and radios from a variety of different sources to provide a LoRa Alliance network or LoRa network for yourself. So let me focus on the cellular standards. So three of them, really the two that are in existence today and one that's coming along. You have the LTE Category M, which is using narrower bandwidth than the standard 4G LTE that is in place for cellular phones today. And obviously, because your bandwidth is lower, you're going to get a slower data rate. Now, in addition to that, you have this narrowband LTE, which is even slower because it uses a really tiny band. And I'll give you some more details, technical details on those two in a moment to show you the basic differences between the two. And obviously, now you have 5G cellular coming along. Now, I want to very, very clearly emphasize that LTE-M and NB-IoT are absolutely part of the 5G standards. It's how you're going to achieve the massive scales that are necessary for large IoT deployment. Now, 5G cellular also makes network improvements to go to massive scale where a large number of devices in a given footprint would not impact the network as badly as a traditional LTE or even a 3G radio might do today. These standards are being finalized literally this year as we speak, and obviously the carriers are deploying the high-speed versions of 5G, but they will be coming out beyond the LTE-M and beyond the NB-IoT with the next generation version of 5G, which will in the network, which will support these technologies going forward. I want to emphasize one thing, that the first two of these categories are now labeled together by the GSMA, the organization that manages the information about GSM. They call it mobile IoT. So when you hear the phrase mobile IoT, it refers to these two technologies. There used to be a couple other standards that were being worked on, which are no longer in play. So these two are the ones that GSMA is focused on. Mobile IoT refers to both of them. If you go to their website and you do a search, you'll see the information associated with these two technologies. Now, what are the reasons for people having NB-IoT and why might you pick one over the other? Let me compare it to LTE. Okay? NB-IoT has low data rates and, as I mentioned, a longer battery life. I'll give you some technical details in a minute. Higher latency than LTE-M because these devices are expected to be sleeping most of the time. They're only transmitting periodically. So if you have a non-critical application like a garbage collection device or a meter reader for water or a non-precision agricultural device that may be making measurements on water quality or water availability, etc., that's the best fit for an NB-IoT device. LTE-M uses a bit more bandwidth. It is more compatible with the LTE network as they exist today. And so you get more data. You can have both fixed as well as physically mobile applications. And obviously, because it has better latency, it can do a better job than NB-IoT for near real-time data communications. And it's sort of similar to what LTE can provide, pure 4G LTE can provide. Mission-critical applications, therefore, are better in LTE-M than NB-IoT. Obviously, if you need high throughput, you would pick LTE instead. Neither of these two are really designed for high throughput applications. Power consumption for LTE, however, it could be a lot higher. And therefore, if you're trying to operate on batteries, you probably would pick the top two. You would not be able to design a solution, a device that would work well with LTE and not use too much power. You'd have to worry about recharging your batteries, or you'd have to worry about a source of electrical power beyond the batteries. Here are the basic technology differences between LTE-M and NB-IoT. The ranges are pretty significant to the nearest tower. So if you're outdoors, an LTE-M device can transmit to a nearby tower somewhere between 1 to 5 to 11 kilometers. If you're using narrowband IoT, you get a little bit more range out of it. But again, this is outdoor range. If you're indoors or inside a place where the transmission levels would be necessarily single strength would be lower, that range obviously gets reduced. But it's pretty significant that you don't have to worry about having a gateway inside your house or something like that. If your application happens to be for home automation, you can transmit a significant distance. LTE-M shares the bands with LTE. NB-IoT can be a little bit more flexible. It can occupy guard bands within the various LTE bands that are available. And as you can see, the basic difference in bandwidth, LTE-M is only 1.4 megahertz, which is larger than NB-IoT at 200 kilohertz. 1.4 megahertz gives you a certain data rate, somewhere near a megabit per second, whereas 200 kilohertz really cannot exceed 150 kilobits per second, and usually it will be less than that. So you can start seeing the difference between the two in terms of capability and capacity. But the very, very important difference is the battery life. LTE-M, you'll probably be somewhere between 1 to 5 years of battery life if you're sending some small amount of transmissions per day. And you might have to do some significant sleep mode use or power the device off if you really want to extend it all the way to 5 years. On the other hand, NB-IoT, which is typically designed to stay off most of the time, for the applications that will use it, you could in theory get up to 10 years, possibly a tad longer. Now, battery technology would need to be carefully looked at. You'd have to have a battery that could sustain itself that long if you didn't want to touch it. Finally, a very important point, LTE-M has voice available to it, not as good as in a pure LTE service, but still sufficient that if you needed to have an application that needed to support a human voice interaction, you wouldn't choose LTE-M and you wouldn't do NB-IoT. I'll give you a little bit more detail in a few minutes about why you might pick one over the other. Here's the example. Your use case basically drives the choice you would make. If you do not need real-time data and you need a small amount of data being sent, then NB-IoT will work perfectly well. If you need voice, then you really have no choice. You have to do LTE-M. There is no voice available in NB-IoT. So the quality of voice in LTE-M obviously will not be as good as LTE, but it will be sufficient for the purpose of your application, most likely. If you need long battery life, then you absolutely would choose NB-IoT, barring all other factors, such as the amount of data, et cetera, because it will give you much more length of device operation on batteries than LTE-M would. Do you need some real-time communication? Well, you're going to need LTE-M, preferably over NB-IoT. Now, the lower cost radio differences is not that significant, but it adds up. So if you have lots of devices deployed, if you have 1 million or 2 million, or ultimately, hopefully your application is very successful and you have 10 million devices deployed, the difference in price starts becoming nominally significant. Today's NB-IoT radios would probably be $1 or $2 less than LTE-M in the future in large volumes. That's an expectation that will change over time, so I'm not going to give you specific numbers and specifics. But today's LTE-M radios generally support NB-IoT as well in many cases, so the choice of technology becomes more dependent on your application than anything else. Is your application physically mobile, meaning does it move as a part of its operation? Does it transition from one boundary, switch boundary to another remote switch boundary, different towers, etc.? LTE-M has mobility management built in, whereas NB-IoT does not. So these kinds of choices will be driven really by your use case. What is the application you're going to deploy, and how are you going to use these technologies for the applications that you have in mind? So it becomes very dependent on that. So let me dive right in and talk about some information about coverage. Now, where is LTE-M and NB-IoT available? Now, this chart is from the GSMA. What they did was they took a compendium of all the carriers that are providing these technologies, including our services that are available in these footprints, and made a categorization of the purple countries shown in purple, where you have both NB-IoT and LTE-M available. And they have the yellow countries showing where they only have LTE-M networks available today, and they don't have NB-IoT available yet. And they also show you the countries where they have NB-IoT in the blue, the light blue, where they don't have LTE-M deployed yet. Now, this will obviously change. I've been watching this chart for the past few years, and it's been steadily growing, not only in terms of the countries that have been added, but also in countries where they only had one or the other networks. Now they have both. And as you can see in North America, in the United States, both NB-IoT and LTE-M are available. We provide that service to our customers, as well as in a number of the countries in South America, a number of countries in Europe, Australia, whereas the NB-IoT networks tend to be more in the Far East, as well as Russia and some of the countries in the Middle East and in Africa. Now, this is going to change. So if you're thinking of doing a global deployment in time, or you're starting in North America and expecting to scale globally, in time, you'll see other countries deploy these networks, and the services will become available. Now, in a large number of these countries, today, you could deploy LTE, and you may already have 2G, 3G, and they will continue to work for a number more years, but you'll need to make a transition to one of these new technologies in time. Somewhere between 2 to 5 to maybe a maximum of 10 years, you'll start seeing the 2G, 3G change to the point where you'll need to have either LTE or LTE-M or NB-IoT network solutions out there. Let me take a few minutes to also identify the sort of the applications that LTE supports, not just the narrowband IoT or the LTE-M, but what could you do with higher performance LTE? This is, I think, a very good chart from Sequans, which shows you on the left axis the data rates that are available, and then the categories of the LTE that are available. The bottom lower left would be NB-IoT, going upwards towards LTE Cat4, and potentially even higher speed performance devices that are available for radio modules today in the LTE space. In the NB-IoT, sensors, parking controls, HVAC control, lighting systems, monitors for pollution, maybe industrial monitors, basic technologies, deployments where you're gathering a small amount of data and you're basically sending that information back without worrying about latency too much, without worrying about real-time data too much. And as you start going higher into LTE-M, you start looking at tracking systems, patient monitors, maybe a personal emergency response device, Emperor's device, where you need information more in real time, more data to be sent, etc. And as you go up the chain into LTE, category 1 or 4 or higher, you're looking at data devices where you're going to be sending many, many megabytes in a connected application for either in each session, or the throughput requirements may be significantly high if you're using it as a router-capable wireless device, all the way up into the hundreds of megabytes, potentially gigabytes per month of usage. So the idea is that you can have LTE category 1 and higher devices for high throughput applications, whereas you typically use LTE-M or the NB-IoT devices for lower throughput, less concerned about latency kind of devices and applications that use those technologies. Obviously, the choice depends on the application. So I'll spend a little bit of time explaining what might be available and possible. Now, next slide, I'm going to talk about 5G. Where are we going here with 5G? What were the technical objectives for 5G? You see 5 basic objectives listed over here. These were the original intent behind how people going to deploy 5G. You'd have 1,000 times more data volume. So you'd have smartphones sending gigabytes today, maybe sending even tens to hundreds of gigabytes in the future. Connection devices, 10 to 100 times higher numbers, somewhere between 50 to 500 billion devices. Large numbers are deployed globally. This is what 5G is expected to support. High data speed, all the way up to 10 gigabits per second, between 1 and 10 gigabits per second, with very, very good latency, a few milliseconds end-to-end, requirements for being able to do streaming of application data or video data or something that would require very, very good latency. And finally, 10 years of low power operation using batteries. Now, it's important to keep in mind that these 5 objectives were not necessarily going to be available simultaneously. In particular, and I'll talk about this in a minute in another slide, if you do very high-speed data transmissions in the gigabits per second, then you're not going to get 10-year battery life. That just simply is not possible. It's technologically and physically impossible to do that. So you have to pick and choose which of these objectives are important to the application you have. Will a smartphone be able to do 10 gigabits per second in time? Perhaps. But will a smartphone battery last 10 years? Absolutely not. Will a narrowband IoT device give you 10-year battery life? Yes. But will it be able to do 1 or 2 or 3 gigabits per second? Absolutely not. So you've got to balance those objectives out based on your application. So it is a good chart from Intel, which I think describes to you the capabilities that 5G allows you to look at. So you can do certain amount of massive machine communication, where you have large numbers of devices, but you're not going to do mobile broadband, etc. I'm not going to go into the details of this slide. People can feel free to download the specific and see what the objectives were for 5G to understand what 5G was trying to do, which was to collect all of these various needs, whether it was high speed or large scale and low latency, whatever it was, and combine them into one service standard that people could then deploy. If you look at the use case projections from the GSMA, you see that their expectations are that about 74% of the use cases will be in the sort of the ultra-fast access to the internet, the enhanced video capabilities, the early applications of augmented reality, virtual reality, etc. About 20% would be the massive Internet of Things use cases. If you have smart homes, smart cities, and low data rates devices that are basically being deployed at large scale. And the bottom right is the ultra reliable low latency communications, for example, in the connected car space, or very advanced augmented reality, virtual reality applications, and mission critical broadband applications in the IoT space. Very cool that they were able to break this down with their expectations, so you can see how 5G fits into the requirements for these kinds of devices that are out there. They also identified a application, let's see, applicability, if you will, for the 5G space. On the left axis is the latency. On the bottom axis is the throughput. And what they said was that you can cast these devices in here based on, you can place these device applications in here based on the requirements for latency and speed. Bottom lower left corner, you have the monitoring sensor networks, which don't worry about latency as much. They don't need a lot of data rate, all the way up to the upper right, where you can do things like virtual reality, augmented reality, tactile internet, where you literally physically use devices that could physically allow you to perhaps remotely do things like remote surgery, and the extreme example of that, if you will, etc. And other applications that fall in between. So the interesting thing about this one slide, and I want to make sure people realize this, the white box, the white rectangle, which goes from monitoring networks to the multi-person video calls, can all be served today by 4G. It's the gray area where 5G, which starts becoming much more effective at providing these services. And obviously, once you have a 5G solution, and even doing real-time gaming or multi-person video, which is sort of the upper limits of a 4G environment, you could, in an LTE 4G environment, you could use that 5G technology that would be available at that time. So good example of how you can fit the bandwidth and latency requirements for what kind of usage that you can do for those kinds of applications. Timelines, so I'm going to give you a approximation of what's been happening. Trials for 2017 through 2019 for 5G. People started deploying 5G in various countries around the world in the 2018 timeframe. What spectrum did they use? I'm not going to go into the bits and bytes and details, but really the bottom line is 2020 is probably the year where 5G comes of age, certainly in the large urban areas in many of the countries around the world, not all, but many of the countries around the world. And then as you go to 2022 and 2025, you see a much higher rate of adoption of 5G technologies. Important to keep in mind that IoT will not necessarily start using those high data rate technologies because, as I mentioned, massive scale is probably going to happen with the low data rate devices. So using NB-IoT and LTE-M for the next 10, 15 years is totally viable, and mostly also because those two technologies are part of the 5G deployments. Ultimately, when 5G comes of age with the network support to support massive scale, then we'll be able to really go into the billions of devices that people are predicting will happen in that area. I want to then talk about 5G and IoT futures. There are clearly some IoT applications which require high data rate, which require the ability to communicate in semi-real time and near real time, maybe even ultra low latency for some kind of control functionality that needs that capability that 5G offers. Those applications will benefit. Obviously, if you have a low power, low data rate device and application where you don't need a lot of data, you don't need to be able to get it there instantaneously, what 5G has is the extensions of LTE-M and NB-IoT that are absolutely available today. You can use them in many countries. You can use them as a migration path from 2G, 3G devices to the new technologies that are being deployed and have been deployed in many countries. Essence to massive IoT growth is long battery life. If you deploy 1 million units and you have to go and replace the batteries every month or 2 or 3, it's not going to be a viable application. So The whole point behind deploying these technologies is to provide you a long battery life so you can go 1 year, 2 years, 5 years, 10 years down the road before you have to worry about changing the battery in a battery application. Final point, as I mentioned, 5G will take some time to achieve the coverage. Today, you can do fixed location, last mile use cases. Absolutely. If you have 5G available, you can start putting in fixed devices. But the general usage of 5G by a large number of the IoT applications is still years away. My own personal belief is it's going to take somewhere between 2 to 5 years, perhaps 4, to get 5G to the point where the pricing, the availability, the coverage will make sense for a large-scale deployment of 5G radios for IoT purposes. Today, LTE-M and NB-IoT provide that, and they continue onwards. Important to keep that in mind, that you're effectively using 5G today by using those two technologies. Now, I want to give you an idea about other technologies that could relate and sort of what kind of application, a typical application, would be served by those technologies. And I've categorized them into 6 areas here: short range on the upper left-hand side, all the way down to the proprietary LPWA, to the 4G, the standards-based LPWA, the 5G, and the satellite coverage that you might be able to use for some IoT applications. I give you sort of the key objectives and the key characteristics associated with that objective to give you a feeling for what kind of applications could make effective use. I'm not going to go through every item on this chart, but I'd like to sort of discuss a few of them. So for example, if I pick the uppermost line in short range where I have less than 10 centimeters to go for a transmission, there is a technology called near field communications, or NFC, which is typically available in most modern smartphones today, but it could be used for an IoT application. I use payment as an example of that, even though payment is not really a IoT application, it's a consumer application. If you look at DSRC, or the short-range radios that is being used for vehicles in Japan, and is going to be looked at in Europe, along with a technology called CV2X, cellular V2X, those have very good latency, less than a millisecond latency between radios, and potentially range up to a couple of kilometers. That would be well suited for V2X applications, vehicle to infrastructure applications, vehicle to vehicle applications. Autonomous vehicles to a limited degree, some functionality of autonomous vehicles could be served by that, but please don't expect DSRC and CV2X to be an absolute panacea for all autonomous functionality. There's some applications inside an autonomous vehicle where you really need real-time processing using LiDAR and other mechanisms, sonar, to keep the issues associated with autonomous driving within the large, dense urban areas down to a minimum. And go down from that into proprietary LPWA served by the LoRa, Sigfox, and NGNU networks for sensors, for example, gives you long battery life. And you have the typical 4G coverage widely available today, where people are using the traditional IoT applications that many of you have probably heard of: connected cars, industrial IoT, medical devices, etc. Those are all served by LTE Cat 1 and higher devices. Typically, if you need video, for example, you might do a Cat 3 or Cat 4 radio, etc. All the way up to 600 megabits per second could theoretically be available if you choose to use a smartphone category 18, for example, handset for transmitting your data. I'm going to walk through a few more items and just dive into satellites, since I haven't talked about that much. There are some LEO, low Earth orbit, and geosynchronous orbit satellites that allow you to do transmissions with tremendous coverage, global coverage. Some of these LEO satellite networks are still being deployed. You'll see them happening within the next 2 to 5, 6 years, and they will provide you global coverage if you have a remote device that's out in the middle of nowhere. Outdoor devices at sea, for example, or in the wilds of an area where you're doing monitoring of air quality, perhaps, or watching applications that are watching for environmental conditions out in the middle of nowhere, where perhaps you're monitoring earthquakes, etc. Things like that. A LEO or a GEO solution might make a lot of sense. And of course, you see the latency can be reasonable, not fantastic, but very reasonable for the kind of applications that those units are capable of doing. In the GEO case, when the satellites are operating, for example, at 23,000 miles above the Earth, there's a basic physical limit of 550 milliseconds of doing a round trip. You add on all the other infrastructure elements that are associated with that data transmission, so you probably get a second of latency out of that. Anyway, this chart, I think if people examine this later on, it sort of gives you the kind of technologies that are available and what applications might be best served by those applications, sort of a typical application usage. So how do you make a choice? How do you decide what to do? I couldn't have provided this level of detail into every application that's out there. So I chose to pick one. I just said, let's look at smart city applications. Let's look at the needs they have. They need to do everything from street lighting to trash, garbage truck management, to energy management, maybe building management if there's a city-owned building, traffic lights, utilities, etc., all the way down to the city vehicles that the employees of the city use. How can I provide a match between the technology that's available to those kinds of applications? So I've listed all of the possible technologies that you might find available to you: Bluetooth, Zigbee, Wi-Fi, mesh networks that are out there, which I didn't really touch on, but they're available for use in many, many parts of the world. Private LoRa Alliance networks, proprietary LPWA like Sigfox, cellular LPWA, such as the NB-IoT and LTE-M technologies, or 4G LTE, 5G, some of the newer technologies that are coming along, the SRC, CV2X, as well as satellite. And I've broken this down into possibilities. Obviously, some of those applications, let's look at energy management. You could use everything from Bluetooth to 5G, depending on what kind of energy management issues you were concerned about. If you look at emergency vehicle response time, obviously it's a mobile device. I'm not going to do Bluetooth. I'm not going to do Zigbee. I'm going to have to worry about a cellular data transport. And if it's truly emergency vehicle, I might need to worry about availability of multiple services. Maybe I'll have both a 2G, LPWA solution for some of the information from the vehicle, or I might have a 5G radio in there, or maybe even a CV2X radio in there for really controlling, managing, gathering information from the vehicle, which might need to monitor, which might need to interact, for example, with traffic lights. So this kind of chart can be put together for any application in the IoT domain, where you can have smart cities, smart homes, connected cars, you name it. This is the kind of analysis that you can do to see what fits and then make a good choice based on price performance. A 5G radio today is very expensive. Cellular LPWA is a lot cheaper. So you might balance that today and transition from one to the other in time. There's no way for me to go into detail and provide you a slide on every one of these possibilities. If you need assistance with your application, your device, your specific use case need, feel free to contact us. We have a tremendous sales engineering staff that can help you figure out what the right technology for use would be. Obviously, our own proprietary services, we worry about, our own connectivity services, we worry about all the way from cellular LPWA to 4G today, 5G in the future, and we're looking at other technologies to support them. We do have customers who are doing hybrid Wi-Fi cellular solutions, but we don't actually provide that Wi-Fi solution. We've managed the device for them for that application, that technology. Important point to remember, you may need to use more than one transport. You may have a unit that has an LPWA radio inside there because you want to be able to send a small amount of data for diagnostic information, perhaps from a vehicle. But then you may need to have a 5G solution or maybe even a satellite solution for redundancy if you have an emergency vehicle that needs to have the data being sent back regardless of the cost associated with doing it. So think about that. You have applications, you have the technologies available, you can figure out the right match for yourself and how you transition from 2G, 3G today to an LPWA solution, possibly 5G, and start using some really long-range services like satellite. Summary. We have new LPWA technologies that are available. These are low-power battery-operated devices. Service providers can deploy LTE-M and NB-IoT today. They're making it available. It integrates reasonably very well with existing 4G, certainly in the case of LTE-M. Narrowband IoT, the carriers have to do a little bit of network changes to support that, a few network infrastructure changes to support that technology, and therefore not every country has NB-IoT necessarily available, but it's starting to become pretty commonly available. We recommend LTE-M for the majority of cases where you don't have to worry about the 10+ years of battery life, because that availability, service availability is better, the radio availability is better, and obviously it integrates well with existing 4G, so you could in fact use that technology where you expect to be able to see LTE available today. So moving from 2G and 3G to LTE-M is excellent. The coverage is generally matching all the application needs. Not everywhere. Some countries, LTE-M is still being deployed, but certainly in North America or Europe, and people looking to deploy units in the United States and North America looking to scale, they will be able to use LTE-M very easily. Obviously, as the deployment costs drop, large-scale IoT applications will start taking advantage of these technologies, particularly the LTE-M and NB-IoT technologies. And today, carriers are rapidly deploying 5G in the urban areas. No issues with that deployment going on today inside urban areas. Longer range technology, longer range use, perhaps on highways or secondary markets or even tertiary markets for 5G, is still a few years away, and I would not expect customers to have that available to them probably till 2023, 4, or 5. That will be the time frame when 5G will be more ubiquitous than it is available today. Obviously, if you have a need for high performance, start with 4G LTE, maybe a Category 3 or higher performance radio, and then migrate to 5G as and when the coverage and radio becomes available for you to use.